Hello everyone, my name is Finding Pepper and welcome to the tile-scrolling platformer expansion, where we are expanding on a tutorial series made by Griffpatch. This episode we will be adding warp pipes. The system I'll be using for these involves placing a certain tile which will signify that the pipe can be entered. This allows us to choose what pipes we want to be enterable, and it's also just a bit easier to code than maybe some other options are. It even allows us to warp through tiles that aren't even pipes, so that's kind of fun. As usual, we'll start out by grabbing assets from my assets project, which there is a link to in the description. Here we are. I will find the sprite called TSPE Warp Pipes and drag the whole sprite into my backpack. Great, now head back over to your project, open up your backpack, and drag out the sprite. We'll drag all our costumes into the tile sprite. You see, we have arrow costumes for the tiles that signify that a pipe is enterable. You'll notice we have 4 different colors of arrows. This is so we can control what pipes the pipes in the overworld lead to. So red arrows will always lead to other red arrows, blue arrows to other blue arrows, etc. Now, this doesn't mean we're limited to the amount of colors we have. We'll code it so that we will be able to use one color for multiple pipes, and it will just send us to the nearest pipe of that color arrow. However, having 4 colors allows us to have a bit more control, especially if our subworld is not of the same width and height as our overworld. The first thing I'll do, I'll just briefly add our pipe tiles to the tile shape and tile key map list. I believe the pipes are under key number 1, so we'll add up to 77, and then in tile shape we'll just add a hash for all of our pipe tiles. Great. While we're here, I'll also map our arrows to a key. I'll use a key we haven't used yet, so 8, I guess. And we won't be worrying about those quite yet. So I'll go ahead and hide the tile key map. However, just so we don't forget, I'll add a when 8 key pressed, next brush 8. Let's just briefly check that we can't place down our pipes. Oh, and we can delete our asset sprite because we got everything we need from here. Okay, now we can try this out. Just place the pipe down over here, and that looks good. You may remember that our pipes that we already had our tile sorting feature. You're welcome to add that to our new pipes. This does make it a bit difficult to place our downward facing pipes, because generally we would like to not have the pipe face on both sides, only one side. To fix this, you can hold down space or press Q to turn off the auto tiling, or figure out a system you like better, but I'm not going to be too concerned about that in this video. So let's actually add subworlds. Now I'm going to add the system of subworlds before we add entering and leaving pipes, and we'll be able to switch between them in the editor as well. So I'll make a variable called subworld for all sprites. And this will be 0 if we're on the overworld and 1 if we're in the subworld. Theoretically, you could have more subworlds, but we won't be doing that today. Now we have to think about how we want to store our subworlds. And I'm going to use our level store list and store them as separate entries in this list. This seems like the easiest way to me, because we already have loading features for this. However, this means we'll have to go down through all of our levels and add an empty item after each of them. And this is in the level store list. Once we've done that, we can turn to our save and load scripts. Now, it turns out we don't have to modify these that much, and that these are the only things we need to modify. We can actually keep our level number variable the same and just change the input to save level and load level. Our overworld level will be level number, and then we need to multiply it by 2 because now we have 2 entries for each level, and then we subtract 1 to get it to be the first entry rather than the second. Then to this we can simply add subworld. So if subworld is 0, it will give us the first entry for the level, and if it's 1, it will give us the second. Now we can just copy this input over to when I receive level load and put it as the input for load level. And now all we need is a system to switch between our subworlds. I'll do that in the editor sprite. When a key is pressed, I'll just use the P key, I guess. Doesn't really matter. We'll want to make sure we are in the editor, so if editor is less than 1, then stop the script. Before we continue with the script, let's stop the game loop. So broadcast level stop. I don't know why there's 3 exclamation marks, but cool. We'll go ahead and save our level, so any changes we made to the subworld will be saved when we switch between them. Now we actually need to change our subworld variable, so we can do this by simply setting subworld to 1 minus subworld, and this will toggle it between 0 and 1. Then we can load our subworld, broadcast level load and wait, and then finally start game loop. And we do not want to wait for that, because this message triggers a forever loop, so it will never resolve if we have broadcast and wait. Let's try this out. I'm going to press P, and seems like nothing happened. However, if we look at our subworld variable, we can see it is now 1. Now I'm going to make some changes in this world, then press P again, and now we see we are back in our overworld, and it is indeed a different world. It's simply because when we load a new level, it makes a copy of our current level. Now, when we run the project, we may notice that we start in the subworld, if that was where we last left off. So in Mario, when flag is clicked, up at the top, I will set subworld to 0. And also, in Mario Lose Life, down before we respawn, I will also set subworld to 0. Let's also do it in the editor when we load a level, so that's under when L key pressed. We'll also set subworld to 0. Let's test it all that working. When we press the flag, we have a subworld of 0. Let's enter our subworld and try loading a different level. It's also a good test just to make sure the level loading system still works, and it appears it does. Awesome. So that was pretty easy. Now it's time to do pipes. First, we will add our arrows. Let's try running the project and placing one down. Press our 8 key, and then place it down. First thing we notice, when we exit the editor, it still appears, and we do not want that. We want it to be invisible when we are not in the editor. So, in tiles, when I receive position tiles, below this initial if-else statement, I'll check if editor equals 0, and our tile is in the range of our arrows. For me, it's 78 to 93, so I'll check if tile is greater, and then we put 77, so it includes 78, and less than 94, so it includes 93. If this is the case, we will hide. Then otherwise, if tile index is greater than the empty value, meaning that we are a clone and not the editor brush displayer, then we will show. Okay, let's run this, and our arrow should now disappear when we are not in the editor. Great, looking good. Now I'm going to quickly go into our subworld and put down a pipe. I'll stick with a vertical pipe for now, just to keep things simple. And I will also put an arrow here on this side. Now we've got that, we can begin coding our pipes. In the Mario sprite, we'll find the check around player block, check around player at. Here we check for specific tiles around the player. If we look at our pipe entrance costume, we'll see that the down and up ones are off center a little bit, and that's because the pipes are 2 blocks wide rather than 1 block wide. This means that we will need to get tile at. We will replace our x with an x minus 16. So we're getting the tile a half block to the left of the player because the arrow costume is shifted over a half block to the right. Now we can check if tile is in the correct range. So with an and, we use the same numbers we did in the tile sprite. If tile is greater than 77 and less than 94. keep in mind that these numbers are probably different for you. Now we need a way to keep track of the color of pipe we entered, the color of the arrow, that is. So we'll make a new variable called pipe family for all sprites. And by family, I mean the family of 4 arrows of the same color. This variable will hold the tile number of the first of those pipes. Now we need a key input, so if key down arrow pressed, remember we're starting with only the downward pipes, and then we should also make sure that we are standing firmly on the ground, so falling is equal to 0. Now we can set our pipe family block to tile, and we will broadcast a message, enter pipe. We will create a new one. When I receive enter pipe, and here we're going to be playing a multi-frame animation, and we need to stop the other script in sprite, which includes the game loop. So stopping other scripts in sprite will stop everything except for just this script. Let's begin by setting some variables to 0, just resetting some variables. We'll set falling to 0, set jumping to 99, so we cannot jump the frame we leave the pipe. And I'll also set player frame to 0, so we animate well, so we display the normal idle costume. We then need to make sure we are behind the pipe, so go to back layer and go forwards, layers, background, layers. Let's get a sound effect for our pipe. I'll go into the sound sprite, and you'll see we have a warp sound effect, which coincidentally is the same as the power down sound effect, but I'll just drag this into the Mario sprite, and when I receive enter pipe, we will also play that sound. So start sound warp. Now we need to find the location of our pipe in the opposite subworld. So to do that, first we need to load our other subworld. I will set subworld to 1 minus subworld, just like we did in the editor, and then broadcast and wait level load. Once we've loaded our level, we can check for a pipe. If tile grid contains pipe family, we'll set our tile index to item number of pipe family in tile grid. Once we've found our tile index, we need a way to set our x and y positions. I'll make a block called get position of tile index and an input tile index, run without screen refresh. I will use this block here and get position of tile index, just like that. Now we'll use our tile grid x and tile grid y variables to store the x position of the tile itself in the grid. For the x, we need to take the floor of tile index divided by grid height, because remember, our grid list stores all the tiles in a row and then all the tiles in the next row, etc. So when we move right, we change our tile index by grid height. So it makes sense that we need to divide by grid height then to get the tile's x position. For the y position, tile grid y, we'll set that to tile index modulo grid height. And modulo is remainder. So once we've divided our tile index by grid height, the remainder is how far up we are. Now we can set our actual x and y positions, and this is simple. X will be tile grid x times the size of the tile, which is 32. And then to this, we need to add 16. Without the plus 16, it will put us on the corner of a tile, but we want to be in the middle of a tile, so we need to add half a tile width, or height, or whatever you want to think about it. Now we set y to the same thing, but replace tile grid x with tile grid y. And we'll also need to subtract 16 this time, because they're originally centered on the top left. So back in our enter pipe script, now we have our new position. We're going to update the camera's position as well to match this, so the camera's position immediately jumps to the player. And because we're doing this, we should also limit our camera's edge, x of 272 and y of 180. Now we can go back to the front layer, and finally, broadcast, level, continue game loop. And real quick, back in our check around player add block, I realized I put a key down arrow pressed. What I should really say is if down of controls is greater than 0. And so this will allow us to use WASD as well. Let's try entering a pipe and see what happens. And press our down arrow. And now we are in our subworld. Now you see the positioning of Mario is a bit off. We'll fix that. Also, if we hold down our down arrow key, then we will quickly switch between the two worlds over and over again. And if you have better performance than me, then that might happen instantaneously, in which you would go immediately right back. That would not be good. For the time being, I'll just have a repeat 10 when we enter the pipe, broadcasting position tiles, and also using our paint sprite block. And I'll put it right after we start our warp sound, but before we change our subworld. So it will just pause for 10 frames and then go through the pipe. Let's try that. So now we get a pause, and now we are through. Let's fix the positioning when we come out of a pipe. We want them to come out of the pipe standing firmly on top of the pipe with their feet planted on the ground. So first we'll change X by 16 so that the player is standing in the middle of the pipe rather than on one side. Then we'll change Y by -16 plus height. So we have -16, so we move down to the bottom of the tile, and then we move up by height so that our feet are what's on the bottom of the tile. Here we can reattach these blocks. Let's try entering our pipe. And now we spawn exactly on top of the pipe on the other side. Now, this system does not account for pipes going in other directions. So let's add that now. So let's take another look at our check around player at block. Where we set our pipe family, here we are setting pipe family to tile. However, no matter the direction of our pipe, we want the pipe family to be set to the same thing, if the arrows are the same color, that is. So we need to set pipe family to something different. We have 4 directions, so maybe we could round it down to the nearest multiple of 4. Let's try that. We'll divide tile by 4, then take the floor, and then multiply by 4. I'll put that in place of what we have there. But this is not quite right, because this assumes that our arrow tiles start with the first one having a tile number divisible by 4. But that's not always the case. Let's take, for example, our first tile, or my first tile, 78. This will give us 76, but we want it to give us 78. And if we look at 80, which should be in the same family, it will give us a different result. So we need to add to this the difference between your first arrow tile number and the multiple of 4 that is next lowest to it. So to my tile, I will subtract 2. And then, once we're done with this rounding, we can add back the 2 that we subtracted. Let's use this instead. Keep in mind that you will need to change this 2 number. If your first tile is divisible by 4, then this will be a 0. If it is 1 more than a multiple of 4, then you'll subtract 1. If it's 2 more, then you'll subtract 2, and if it's 3 more, then you'll subtract 3. We should also create a variable to hold the direction of our arrow, called pipe direction for all sprites. I'll set this along with pipe family. This time we need to replace the division with modulo, and we only need this inner part, tile -2 modulo 4. This one's a bit simpler. Again, you need to change the 2 to whatever you have up here. Now, the pipe direction will influence how we enter the pipe, or what control we press. So we should actually move these 2 things outside of this if statement. And we can add a stop the script after enter pipe, and we check for each of the directions. If pipe direction equals 0, meaning it is down, remember the down arrow is the first of the costumes, so that's why it's 0, and we're starting with 0 because it's modulo. Now if it is 1, then we want to move upwards. So if up of controls is greater than 0, and here we can use our jumping variable. If jumping equals 99, then we know we hit our head this frame. Now for the other 2 directions, we will be checking at the center of our player, because those tiles are centered. So I'm going to duplicate this and remove our get tile at because we have one up here. And here I'll check for pipe direction of 2 and 3. For 2, that is if we're going right. So if controls is greater than 0. And we also want to make sure we're grounded here. And that our speed x is 0. Now if our speed x is 0 while we're pressing the right arrow, then that means that we're colliding with something. Now I'm just going to duplicate this and statement and change the right to a left, and that's all. Now in our when I receive enter pipe, we need to modify it to support the other directions of pipes. So for now, we need to change the if tile grid contains pipe family, because now we are searching for pipes not just of exactly the same tile, but also of other tiles in the pipe family. So I'll search for our other directions of pipes by using the pipe direction variable. So we'll start by setting pipe direction to 0, and then I will repeat for each of the 4 pipe directions, changing pipe direction by 1 each time. Then we can check if tile grid contains pipe family plus pipe direction. Okay, so this will check for all 4 directions of pipe. I'm going to move this into a separate custom block called find pipe index. Run without screen refresh. I will move these scripts into that block and put the block in their place right before we get our position of tile index. This allows us to stop the script when we find a valid tile index. When we stop the script, our pipe direction will no longer keep changing, so we will know what direction this pipe is. At the end, if we don't find anything, we'll just set our pipe direction back to 0. Alrighty. Now after we find our pipe index and direction, the amount that we offset the player's position by when we come out of the pipe depends on the direction of the pipe. So what we have here is if pipe direction equals 0. If pipe direction equals 1, we'll want to keep the change x by 16, but now we'll want to change y by 16, positive 16, minus height. So this is moving up to the top of the block, and then moving down so that our head is at the top of the block. However, if Mario is mini, then their actual height is different from what the height variable would suggest. So get an if-else checking for if Mario equals mini, put what we have here in the else, and in the if, we just change y by 16, without the minus height, because the top of their head is actually at the middle of the player. Now for pipe direction equals 2, this is the one facing left. We want to position our x so that the right of the player is at the right of the tile. So this is 16 minus width. We'll keep the y negative 16 plus height, so we are standing on the ground. Now if pipe direction equals 3, that is the right facing pipe, so we change x by negative 16 plus width. And keep the change y the same, and then we attach these. Alright, let's try that out. So let's try going in through this pipe here, and you see we spawn on the other side, correctly aligned with the pipe. Let's go down through here, and yep, this looks right. Okay, also let's see when we go into a pipe to the left, we want to turn around to face the direction we come out. I'll just change that. In the if pipe direction equals 2, we point in direction negative 90, and if pipe direction equals 3, point in direction 90. Let's go through here, and there we go. Awesome. Alright, so now let's add some animation for entering and leaving pipes. I'll start by at the top of enter pipe, setting player action to idle. Forgot to do this earlier. Now, below the start sound warp, we will move our player depending on the direction of the pipe. If pipe direction is 0, meaning we are going downwards, then we will repeat 8 times, changing y by negative 4, and painting sprite, and broadcasting position tiles. So we display each time we do this. 8 times negative 4 is negative 32, so we'll go down a full tile in total. If we're Big Mario, we need to go down further. We can repeat 8 plus not Mario equals mini times 8. When this boolean, that's a true-false, is put into a number input, it will, rather than returning true or false, it will return 1 or 0. So we can use this to our advantage and use it as a number to repeat more times without having to duplicate this code. If pipe direction equals 1, we will do something very similar, this time changing y by +4. If pipe direction equals 2, then we don't need to worry about the Mario equals mini 8 times, and we'll change x by +4. If pipe direction equals 3, we change x by -4. Let's try this out. Go into a pipe, and that seems to work great. Now let's just add the exiting animation. We'll do something pretty similar. Duplicate this code up here and put it after we position our camera. We need to start by changing our y, and I'm going to duplicate this, changing the 8s to 32. And we want to change by -32 and times -32. We're moving downwards into the pipe, so that then in this repeat loop, we can change y by 4, moving upwards out of the pipe. Now if pipe direction equals 1, we'll replace the negatives with positives and vice versa, because we're moving the opposite direction. For the pipe direction of 2, we'll replace the y's with x's. We can remove the whole thing about Mario equals mini, and we can just change x by 32, plain old 32 here, and -4 here. Remember, this is the left-facing pipe. Pipe direction equals 3, facing right. We move to the left, and then repeat 8, move to the right. Let's go into the pipe. Then we come out, very nice. Let's go back in, and then there we go. Now what if we want to use the same color multiple times? I'll have one here, and then one for this pipe here. And I'll use the blue color both times. Let's go in here, then we come out of this pipe. We go into this pipe, we come out of this pipe. And if we go into this pipe, we'll also come out of this pipe. No matter which one we go in, we always come out of this pipe. Let's change it so that we come out of the pipe that is closest to the pipe that we entered. Let's edit our find pipe index block. I'll rename it find pipe index nearest to, and then input x and input y. When we call this block, we can just stick in our x and y variables. And I'm keeping them like this because we will reuse our x and y variables for something else inside this block. We're going to use our temp variable to keep track of the distance of the nearest pipe. At the start, we'll set temp to 99999, just a big number, big enough that really anything will be smaller than that. So the idea is, if the distance of the pipe to our current position is less than temp, which will be the smallest distance so far, then we'll set that to be our nearest index, and we will loop through the entire grid list to make sure we find everything. So repeat length of tile grid. We can use our tile index variable to store our index in the list. Set tile index to 1 each time. Change tile index by 1. I'm going to remove the contents of this if statement. Now we'll set our tile variable to item tile index of grid. Now in our if statement, we want to make sure that this tile is one of the 4 direction tiles in our pipe family. So if tile is greater than pipe family -1, and the -1 is so we include the pipe family value itself in this, and if it is less than pipe family +4. Then, to find the distance, we need to first find the x and y positions of that pipe. So I'll use our get position of tile index and use the tile index variable. Now we want to change our shortest distance, which is the temp variable, if and only if the distance between this pipe and the x and y values input to this block is shorter than the current distance. So that way this distance will always represent the shortest distance. So to find the distance, we can say absolute value of the difference between x's, so x minus our x variable, and remember the x variable is the one returned by our get position block, and then we add our y's, the difference of our y's, and if this distance is less than our temp variable, then we'll set temp to this value. We should make sure to keep track of the tile index of this pipe. We can store that in a new variable called found index. This will be the return value of this block. Here we'll set found index to tile index. And then we can also set our pipe direction to tile minus pipe family. Subtracting pipe family from our tile will result in the pipe direction. Now there's always the chance that we don't find a pipe, so at the top I'll set found index to tile index, and this is the tile index before we begin this loop, and set x to x and y to y. Great. Now let's go to where we use this block. Below this, rather than getting the position of tile index, we'll get the position of found index, because found index is the index of the nearest pipe, whereas tile index is just the variable that's used to loop over the grid list. Let's run this now, and try entering a pipe. Now we come out of this pipe. When we go in this pipe, we should come out of the other pipe. And we do. Okay, this is looking correct. Awesome. Now before we end this, I'm also just going to set our speed x and speed y to 0 when we enter the pipe, because I forgot to do that earlier. And now we are done with warp pipes. If you want to add different backgrounds for your subworlds, then go check out my changing backgrounds tutorial. There'll be a link to that in the description. And yeah, that's about it. Hope you enjoyed this episode. Have a great rest of your day, and goodbye.